RCExplorer HV, exploring the RC world one crash at a time.
This is the Baby Tricopter. It's a 170mm little crazy beast thing, and we're gonna build one. This is what you get if you buy the Baby Tricopter kit with the Baby PDB and F3FC board. Also, we're gonna use the Baby Tricopter electronics kit. This is where we're gonna get the best performance because the default PIDs are gonna be spot on. So let's get started. Before doing any assembly, we need to finish off the carbon fiber because the edges are really sharp and you can cut yourself, and the battery strap and the zip ties are just gonna snap off really easily. Therefore, included in the kit is a crescent-shaped diamond file. Carbon fiber dust is really dangerous though, so put on a breathing mask, gloves, and do this outside. The diamond file has two sides, one that's flat and one that's curved. This is so you can easily get to all the parts of the carbon fiber. It also has a pointy end so you can get into all these little tiny holes. And it's very important that you do not skip these holes because otherwise these zip ties that go into these holes are going to snap too easily. File the other parts as well, and don't forget there's a top and a bottom side to all of these pieces. This is going to take a while, so I'm going to tell a joke. There's a rookie pilot and a co-pilot and they're coming in for a landing. The pilot says, "Darn, this runway is really small. Give me a quarter flaps." As they get closer, the pilot says, "Whoa, this runway is really small. Give me half flaps." As they're coming closer again, the pilot says, "Whoa, this runway is really small. Give me full flaps." After barely making the landing, the pilot turns to the co-pilot and says, "That is the smallest runway I've ever seen." And the co-pilot said, "I know, it's crazy how they designed it. It's so short, but it's super wide." Okay, after you're done with the filing, take a moist paper towel or rag and wipe down the edges. This is so you get rid of all the carbon fiber dust that still might be attached here. Now that the edges are silky smooth, we can start with the assembly. Take out the Baby PDB and the nylon hardware pack. Out of this pack, we currently just need the 14mm screws, the fiber washers, and 4 of the nylon standoffs. The rest of the parts we're going to use later, so put those in a box or something so you don't lose them. Flip the frame over and put the 14mm screws in these holes. Then flip the frame over again and mount the low fiber washers. The reason why we do this is so the Baby PDB doesn't come in contact with the carbon fiber, because the board could short out then. Mount the board so you have the battery pads pointing backwards towards the tail. Mount the nylon standoff so the board doesn't go anywhere. The Baby PDB is capable of outputting 5, 6, 8, and 12 volt. You can select this voltage by soldering on a bridge between the middle pad and any of the other 3. No bridge means it's outputting 5 volt. In this build, we're going to use 6 volts. This means we get a little bit better performance out of the servo. You'll need a pigtail with a matching connector that you use for your batteries. I'm going to use this 5cm long XT60 pigtail that we have on our store. You want to strip the wires quite long so you get good connections on these pads. Pre-tin the wire and then solder it on. Use 6040 solder or 6337 solder and use a good quality soldering iron. Double check your polarity. The red wire should go to positive and the black wire to negative. Now we're gonna do the motors and eecs. I like soldering the motors straight to the output pads on the speed controller. You don't have to do it this way, but you save some weight and it looks really clean. Remove the heat shrink and desolder the wires. Don't forget to add some fresh solder to these pads, or your solder joint is going to look horrible. I'm going to be quite brave and cut my motor leads as short as possible. You might have noticed that I'm making the middle motor lead a little bit shorter. This is so all wires are equal length when they're soldered on. Pre-tin the wires properly and solder it to the board. You want to push down the wire into the solder so it sits against the board. You don't want it sitting up a little bit because that can lead to a poor connection and your motor and speed control can blow up. Now included in the electronics kit is this really heavy duty heat shrink. It's lined with the kind of hot glue that if properly used will seal up your ESC and making it really water resistant. Beware though, it's extremely tedious removing this stuff, so test your ESC and motor properly before shrinking this. While I'm doing the second ESC, I think there's time for another joke. While flying over the Atlantic Ocean, the co-pilot turns to the pilot and says, "Hey Frank, the low fuel light is on. We're all gonna die. We're not gonna make it. We're just gonna go into the ocean. We're all gonna die." Oh, wait. That's just the intercom light. My bad. Okay, just as a reminder, please check the ESC and motor before you shrink this heat shrink. The back ESC is slightly different. Here we're going to leave the full length of the wires on the motor, cut off a little bit at the end and then re-tin the wires. Next, remove the wires from the speed control just as you did before and add more solder to the solder pads to make a really good solder joint. Solder on the motor wires at an angle like this, and you want it pointing to the left if you look at it from the back. Don't like how that solder joint turned out, so I'm just going to redo that real quick. So this is the way you want the wires to point. This is going to make it a lot easier when you put this on the tilt mechanism later. Now test all the ESCs before you proceed with this step. We're going to shrink the heat shrink. Now it's going to require quite a lot of energy to shrink this heat shrink because it's pretty thick, which is awesome because it protects your ESC really well. When it's shrunk all the way, pinch the edges. This is going to be really hot, so like wetten your fingers or use a pair of gloves or something. You want the glue to make a perfect seal around the wires. This is going to stop water from coming into the ESC, which is awesome. And also, this really takes off the stress from the solder joints. Ooh, look at that fanciness. Now we're going to move on to the tilt mechanism. The tolerances on these pieces are pretty tight. When assembled, these parts should move with very little friction. More often than not, you're going to need to sand these pieces. You want to remove enough material to where the friction is low, but you don't want to remove too much either because then you can develop slop in the tail, and that's not good either. Do not sand the side where the servo is going to be pushed into, because that's not going to do anything. Sand the insides of the pieces. When you're done with the heavy grit, you can go to a finer grit and do the finishing pass. Test the pieces often and adjust from there. This tilt mechanism is made from fiberglass reinforced nylon and it was forged in the fires of Mount Doom, so it's pretty durable. You want to test the tilt when the screw is mounted. To reduce friction a little bit, you can over tighten it. Just keep on going and keep on going. That way it's going to kind of sand itself down a little bit because otherwise you can get friction from the screw itself. When you're happy with the lack of friction, you can mount the servo. Just shove it in there and then tighten down the screw so that the output shaft is pulled into the tilt mechanism. Then untighten the screw again. This greatly reduces the friction. If you're worried about the screw coming out, you can just use some Loctite. I personally never had it come out even a slightly little bit without the Loctite, but better safe than sorry. Now the servo spacer goes in these slots. You want it sitting all the way down on the frame. If it doesn't, use the included file and then just file it down a little bit until it fits perfect. You want it to be able to slide back and forth, but you don't want it super loose either. The sliding feature is there so you can remove the servo from the rest of the tilt mechanism. We're going to use this feature later to make sure that the tilt mechanism is flat when the servo is at idle. But now we're going to mount the back piece of the tilt mechanism using 2 zip ties. You should mount the zip ties so that the knots lay flat against the frame. This will ensure that the zip tie is as short as possible and can't get loose over time. You also want to make sure that you mount them in opposite directions so the knot points in different directions. This is going to make sure that the forces on the tilt mechanism are equally distributed. We're not going to strap down the servo just yet. We're going to do that later. But we're going to prep the servo wire. Fold it over like this and then cut it to a good length. This is going to ensure that we have plenty of wire to solder onto the flight controller. Then strip the wire and pre-tin them. Now separate the ends. This is going to make it a lot easier to solder onto the flight controller later. Okay, that looks good. Now put that to the side. We're going to mount the motors next. In the screw pack there's 6mm long screws. We're going to use those to tighten down the motors. Also, always use blue Loctite when screwing anything metal into metal. To save some weight, I'm just going to mount these motors using 2 screws instead of 4. I have yet to strip them out, but if you would strip one, you can simply use the 2 other screw holes the next time you tighten it down. Now, when you mount the back motor, you have to pay attention so that the wires come out the right way. You want them to come out this way so that they don't hit the servo or make the tail bind in any way or create extra friction. Double check that the tilt moves smoothly after this. Remember the wire we cut off the servo? We're going to use that to connect the baby PDB to the flight controller. Cut the wire a little long, it makes it easier to work with. Then strip both ends and pre-tin them. A quick tip is to put the solder on the table and then move the soldering iron and the wire into the solder. Makes it a little bit easier. Okay, now we're going to solder on these wires to the PDB. Start by pre-tinning all the pads. Use the red wire on the top, that's the BEC voltage output. The next one is ground, so we're going to use brown for that. And then the one after that is the current sensor. We're going to use orange for that. And lastly, we have the battery voltage output. We're going to use yellow for that. Okay, we're going to leave that for now and continue soldering on the ESCs. And the first one we're going to do is the back one. This is by far the most fiddly one. So you want to get it underneath the power cables and then bend over the positive lead like this and then cut that. Then cut the black one, then strip and pre-tin those wires. Pre-tin the pads and then shove the speed controller in there again and solder the black one in place first because that's the easiest one. Be careful so you don't touch the soldering iron to anything because you don't want to melt the nylon standoffs or one of the wires. I'm just going to screw off the nylon standoff on this side while I'm soldering this because it's kind of awkward because the wire wants to bend and all that. So take a pair of needle nose pliers and just kind of hold the wire there while you're soldering it on. You can see here why we soldered the motor leads on the back ESC at an angle, otherwise it's really difficult to fit this in here. This looks really good, so we can continue with the front ESCs. One side of the PDB has the positive pads and the other side has the negative. So we need to cut one wire, the positive on the left ESC, short and leave the negative lead long. Solder the positive wire to the top pad. It's going to make it easier to solder on the other ESC positive wire later. Route the negative wire in between the coil and the capacitor. That makes it lie nice and flat against the board and it doesn't take up that much space and it keeps it clean. On the right ESC, you should cut the negative wire short and solder that to the top pad. Then route the positive lead next to the negative lead between the coil and the capacitor and solder it to the bottom pad on the other side. After you're done with this step, double check your polarity. It's super important, otherwise you might blow up your ESC and power distribution board. The red wire should go to the left side marked ESC plus, and the negative wire should go to the right marked ESC minus. On the back, the red wire from the battery should go to BAT plus, and the black one to BAT minus. If you plan on powering anything else from the flight battery, use another ESC plus and minus pad. Otherwise, the current draw is not going to be measured by the current draw sensor. Now we're going to hook up the FPV system. I'm going to use an HS1177 camera and a TBS Unify Pro HV transmitter. It's pretty cool because it comes with a wire that's already made for the HS1177 style camera. So all you have to do is hook up power to the video transmitter and it's going to supply the camera with power as well. So we're just going to solder the positive and negative wires straight to the PDB. If you want to, you can solder these to the ESC power pads, but I'm going to use these power pads on the side. So solder the black wire to the ground and the red wire to the VBAT pad. This way the transmitter is going to be powered straight from the flight battery. Now we're going to turn our attention to the flight controller. This is an F3FC racing board. The first thing you should always do with the flight controller is plug it into the computer and make sure it works. So do that first. If you're having trouble connecting to the board, go watch the TriFlight setup video. This one is working great, so let's move on mounting the beeper. I highly recommend getting a beeper because it's a lot easier to do the tail tune setup later, and also it's good for finding your model after you crash. I'm going to solder mine straight to the board. There's two pads called BZ plus and BZ minus, and I'm going to just bend the legs on this beeper and solder it straight to them. Make sure that you bend the correct leg because there's a positive and a negative on this beeper as well. You don't have to mount it straight to the board. You can use some wire and then just mount the beeper wherever on the copter. Having it mounted straight to the board is going to make it a little bit more difficult to solder on the ESC signal wires later, but it's going to look really clean. Now we're going to solder all the wires to the flight controller. The yellow wire from the power distribution board goes to the positive pad on the VBAT. The red and brown wire go to the large BEC plus and minus pad. And the orange wire goes to the pad marked iSense. Now for the servo wires, the red should go to the pad marked BEC and then the brown to a negative pad. If you solder the wires in the orientation that I did, be sure to measure that there's no short between BEC positive and negative, as you have the other BEC pads just behind it. Now flip the board over and solder the orange wire to the pad marked number 2 and then the yellow wire to the one named FB. Route the ESC signal wires down like this. It's going to make it nice and clean. Use a couple of the nylon standoffs to hold the board in place. Solder the ESC signal wires into place. Be sure to solder both the negative and the signal wire on all the ESCs. That's very important, otherwise your copter is going to catch on fire and stuff. Okay, so these are the pads you should solder your ESC signal wires to. As I mentioned before, it's kind of a pain to solder these wires in here when the beeper is mounted like this, but it turns out pretty clean in the end. I can recommend using a pair of tweezers to get these wires in place if you do it like me. It works pretty good. Yeah, look at that fanciness. Now we're going to mount and hook up the receiver. I'm going to use this FRSky XSR receiver, which is a tiny telemetry and S-bus capable receiver. It also has PPM out. I'm not going to use that, so I'm just going to pop that wire out. I'm going to hook up the S-bus wire to R1, which is RX pin on URT1, and the S-port telemetry to T2, which is TX pin on URT2, and then 5V plus and minus. This looks like a pretty good length for this wire. So strip the wire, pre-tin it, pre-tin the pads, and solder it into place. Ooh, I forgot to mention, if you're going to power anything that draws a lot of current on 5V, don't do that through the built-in regulator on the flight controller. Do that through the BEC on the PDB. Oh, that looks good. I'm just going to fold over the receiver here and mount it on top of the flight controller. To keep it from moving, I'm just going to cut the little piece of this foam and squish it down there, so it's really in place so it doesn't create vibrations in the flight controller. I highly recommend binding the receiver before this step though. I could still get to the little bind button, but it was kind of a pain. Don't over tighten the nylon nuts or you might end up stripping them. Look at that, that's compact and nice, and you can barely see any wires. Mounting the FPV camera is pretty straightforward. Just take them out and drop it down in the cutout. The manufacturing tolerances on these brackets might not be up to scratch, so just use the diamond file included in the kit and file a little bit on it. It should drop in there just fine. You can also use a Runcam Swift or a Runcam Owl. That's why there's two holes in the front. Use the 2mm screws that come with the camera and just screw it into place. For mounting the 1177 camera, there's a 6mm screw and a lock nut included, so just drop that through the hole and tighten it on the back side. The cutout is there to prevent the camera from swiveling. This happens after a really hard crash or when you touch it or you look at it funny, so this prevents that. Now drop in the camera into the middle holes and then use the supplied screws and screw it down nice and hard. The camera actually stays really good in place when you have these screws tightened down, but you can still set the angle without using any tools. This is really convenient if you want to try a new camera angle while you're at the field. Next we're going to mount the battery tray. To do that we need these 6mm thick nylon spacers. So put those on the bottom here where there's 4 holes. Then slap on the battery tray and then shove the 14mm screws straight through. There we go. Now take out the 30mm long aluminium standoffs. We're going to flip the whole copter over and hold your fingers over the screws there so they don't fall out. Then screw on the aluminium standoffs. If you feel like you can't tighten them down enough with just your finger power, you can use a 2mm Allen wrench on the bottom and just tighten those screws down. We're making excellent progress. Now, since I'm using the TBS transmitter here, it comes with this little pigtail that you can screw down. So I'm just going to mark this out and drill 2 holes so I can really mount it properly. I cheated a bit and drilled this off camera, so use your imagination. If you're going to use a video transmitter that has the SMA connector mounted straight to the board, you can use a 90-degree angle converter and then put that through the hole. You can see that in the build log I have on the project page on RCExplorer. To mount the video transmitter, I'm just going to use some of this little foamy double-sided sticky tape things. So I'm just going to slap that on the back and then mount that on the top of the stack. Don't forget to plug in your video transmitter before sticking it on there, because otherwise it's going to be kind of awkward getting that cable in. Screw the top plate down using 4 6mm screws. If you want to, you can use Loctite on these as well, but I kind of didn't. Now we're going to use zip ties and heat shrink to hold the antennas. At the back of the top plate, there's 2 slots that are cut at a 45-degree angle. This is where you want to mount your zip ties. Mount them so that the knots are laying flat against the top plate. Cut the zip tie a couple of millimeters over where the antenna ends. Then slip over some heat shrink and shrink that. I used 4mm heat shrink for this, but I think you can get away with 3.5mm as well. Cut off the heat shrink at the same length that you cut the zip tie to. Then put on another layer of heat shrink and shrink that. The reason why we do this is to increase the stiffness and also the protection for the antennas. And the reason why they're mounted at a 45-degree angle is so that they don't bend into the back motor when you crash. Now go watch the tri-flight setup video. Just remember not to set the board orientation to 180 degrees. Just leave it at 0. Now we need to check and line up the servo with the tilt mechanism. Power up your radio and plug in the flight battery. Activate the tail tune mode on your transmitter. Check how far off center the tilt mechanism is. You want it pointing straight up-ish. Mine looks pretty good. It doesn't really matter if it's off by a few degrees. But if you need to change it, all you have to do is unscrew the screw and slide the servo back. Then move the tilt mechanism so it's pointing straight up and then slide it back on the servo. Most likely you won't get this perfect because there's manufacturing differences in the servo. That's why we have the tail tune setup mode, which we're gonna get to in a minute. But now we're gonna strap down the servo. You'll be needing 4 zip ties because one is not long enough to reach around the servo. So shove one through the hole in the frame and then link that up with the next zip tie. Tighten it down so you have the knots sitting flat against the frame and flat against the servo. Also mount the zip ties so they're pointing in opposite directions. Tighten them down good, but not Hulk strength. Then just cut them off and you're done with that. Back to the tail tune. In the tilt mechanism bag, there's this little servo setup tool, one side of which is a little bit slanted. That's the part you want pointing up. So you just slide that on the frame and then just do the tail tune like instructed in the tri-flight video. There's one difference though. The middle position doesn't have a measuring tool. Instead, use the top plate and sight that against the flat part of the top of the motor. This is actually a really accurate way to get the motor being straight up and down. Don't forget to do the speed calibration after that. I strongly recommend strapping down your speed controllers to the frame. This is so you don't get weird vibrations to the flight controller. You can use zip ties for this, but I'm going to show you something different. This is self-vulcanizing tape. It is fantastic. It's a rubber-based tape that after you stretch it, it fuses with itself. It's really cool. And you can use it to make waterproof seals. But in this case, it's just going to support the ESCs really well. And it's going to give some extra protection. Ooh, look at that. So pretty. Now we just need to mount the propellers. This is the only correct way of mounting your propellers. Everyone else is wrong. This is because the tri-flight firmware is made for this prop orientation, so no other way is correct. Just mount it this way. Congratulations, you now successfully built a baby tricopter. It's time to go out and do the in-flight tail tune. Do this on a really calm day or really early in the morning because it usually isn't windy then. Arm the copter and try to take off. If it doesn't take off, go back inside, cry a little bit, try to find a fault, and then go out and do this again. If it stays in a nice stable hover, you can activate the tail tune. It's going to give you a 5-second countdown. After which, you should move the sticks as low as possible. It will only perform the tail tune when the sticks are not touched. If you move the sticks to correct for like wind and stuff, it's going to pause the tail tune until you release the sticks again. Don't fly too close to the ground like I'm doing here. Fly up in the clean air. After it's done, it's going to beep this pattern. Then, land, disarm, and then turn off tail tune, and all the settings are saved. How long the tail tune takes to complete depends on how windy it is and also how well you set up the tail. It can take up to 2 minutes, but 30 seconds should usually do it. You're now 100% complete and you can fly like a maniac. Thank you so much for watching, and thank you for buying stuff from my store. Also, I want to see pictures of your build, so go to rcexplorer.se/forums. Take care, guys.
milliamp hour.
crap. Man, it's stuck. Wow. It didn't even break a prop. What the heck? Man, that's a tough little bugger. Let's see if it flies. Flies like new. Man, this copter is awesome.